Since the dawn of civilization, humans have stared at the stars, yearning to understand our place in the vast cosmos. Ancient astronomers mapped the heavens with curiosity and awe, while today's scientists have uncovered a stunning truth. The universe isn't just expanding, it's accelerating. Yet the biggest question still looms larger than galaxies themselves. What ultimate destiny awaits the universe? Will it stretch endlessly into an icy dark void, or could it one day collapse in a fiery cosmic finale? Join me as we unravel this breathtaking mystery where science meets the edge of imagination, and the future of everything hangs in the balance. The cosmic question. What if I told you the universe is not just expanding? It might be racing toward a fate so strange and mysterious that it challenges everything we know about time, space, and existence itself. This isn't science fiction or a far-off fantasy. It's a cosmic puzzle that has captivated scientists, philosophers, and curious minds for decades. Will the universe stretch endlessly, growing colder and emptier until nothing remains? Or could it one day reverse course and collapse back in on itself, like a giant cosmic heartbeat pulsing through time? Or perhaps even more unsettling, might it tear itself apart atom by atom, unraveling the very fabric of reality? These mind-boggling possibilities sound like something out of a sci-fi novel, yet they come directly from the most cutting-edge research in astrophysics and cosmology. Today, we're embarking on a journey to explore one of humanity's most profound and thrilling questions. What is the ultimate destiny of our universe? Whether you're someone who loves gazing at the stars or simply want to understand the future of everything around us, this adventure will guide you through astonishing theories, surprising facts, and the mind-bending nature of space itself. So prepare your imagination and curiosity, because the fate of the universe may be far stranger and more fascinating than anything you've ever imagined. The Big Bang and the beginning of expansion. Almost 13.8 billion years ago, the universe had its dramatic beginning, not with a bang as the name suggests, but from an unimaginably hot, dense point smaller than an atom. This moment, known as the Big Bang, set everything in motion. From this tiny speck, space itself began to stretch and expand, creating the cosmos we call home. Early on, the universe grew at an astonishing pace during a phase called cosmic inflation, where it ballooned exponentially in a fraction of a second. This rapid expansion smoothed out the universe, setting the stage for galaxies, stars, and planets to form billions of years later. What's remarkable is that this expansion didn't happen in space. Rather, space itself expanded, carrying everything along like dots on an inflating balloon's surface. Scientists have traced back this expansion through observations like the cosmic microwave background, the faint afterglow of that first moment, which acts as a snapshot of the infant universe. Understanding this explosive origin is key because it explains not only how the universe began, but why it's still growing today. But the real mystery starts with the question: will this expansion ever stop? Is the universe still expanding? For centuries, humans have looked up at the night sky and wondered if the cosmos is static or changing. Then, in the 1920s, a groundbreaking discovery shattered old beliefs. Distant galaxies aren't just sitting still, they're speeding away from us. This phenomenon, called redshift, acts like a cosmic Doppler effect, stretching the light waves and proving that space itself is expanding. But here's the twist: this expansion isn't slowing down. Thanks to powerful tools like the Hubble Space Telescope, scientists found that the universe's growth is actually accelerating. The surprising culprit behind this mysterious force is something we call dark energy, an invisible energy making up about 68% of the universe and pushing galaxies apart faster and faster. Dark energy is baffling because we can't see it or measure it directly, but its effects shape everything from galaxy clusters to the very fate of existence. Understanding how and why the universe keeps stretching reveals not just where we are today but where everything is headed. The cosmos is far from static, it's an ever-evolving masterpiece, driven by forces we are only beginning to grasp. Theories about the universe's ultimate fate. When it comes to the universe's future, scientists have outlined three dramatic possibilities, each with its own cosmic drama. The first is the Big Freeze. Imagine a universe that expands forever, galaxies drifting so far apart that stars burn out, leaving a cold, dark emptiness. Over unimaginable eons, everything fades into silence as heat and energy dissipate. The second scenario, the Big Crunch, paints a very different picture. What if gravity eventually overpowers expansion? The cosmos could reverse course, shrinking everything back into a dense, fiery collapse, like rewinding the universe's own birth. Lastly, there's the most extreme and unsettling idea, the Big Rip. If dark energy grows stronger over time, it could eventually tear apart galaxies, stars, planets, and even atoms, ripping the very fabric of reality apart. Each theory depends heavily on the nature of dark energy and how it behaves over cosmic timescales. The fate of everything we know hangs in the balance between these incredible, mind-bending outcomes. What happens next might rewrite the story of existence itself. The role of dark energy. Among the most profound mysteries of the cosmos lies something both invisible and overwhelmingly powerful: dark energy. This mysterious force doesn't just influence the universe, it dominates it, making up nearly 68% of all cosmic energy. Unlike gravity, which pulls things together, dark energy pushes space itself apart, driving the accelerated expansion of the universe. Scientists first suspected its existence when they noticed galaxies speeding away faster than expected, defying the slowing effects of gravity. But what exactly is dark energy? Is it a constant, unchanging force? Or could it evolve over time, perhaps weakening or intensifying? These questions fuel cutting-edge research and debates in cosmology today. Understanding dark energy is crucial because it determines whether the universe will expand forever, collapse, or rip itself apart. Unlocking its secrets may not only reveal the fate of the universe but also challenge our understanding of physics itself. Dark energy remains one of the biggest enigmas, a ghostly presence shaping everything around us in ways we are just beginning to comprehend. Recent discoveries and changing perspectives. The universe is constantly surprising us, and recent discoveries have started to challenge long-held assumptions about its fate. Some new research hints that dark energy might not be as constant as once thought. Instead, it could be slowly weakening over billions of years, opening the door to a future where cosmic expansion could change course, or slow dramatically. This shift in understanding is shaking up cosmologists, forcing them to reconsider how the universe might evolve. Cutting-edge projects like the Dark Energy Spectroscopic Instrument are mapping millions of galaxies with unprecedented detail to track these subtle changes. These observations could redefine cosmic models and hint at new physics beyond our current theories. It's a reminder that the universe's story is still unfolding, and every discovery brings us closer to answering whether the cosmos will expand forever or take an unexpected turn. The journey to uncover our universe's destiny is ongoing, filled with thrilling discoveries that challenge everything we thought we knew. The uncertain future. The fate of the universe remains one of the most profound mysteries we face, an enigma wrapped in dark energy, cosmic expansion, and time itself. Despite decades of research and incredible technological leaps, scientists still don't have a definitive answer. Will the universe continue expanding forever into an icy, silent void? Or will it someday collapse back, triggering a cosmic reset? Perhaps it will unravel at its seams in a violent big rip no one has yet fully imagined. What makes this question so fascinating is how it pushes the limits of our knowledge and imagination, reminding us that we are explorers in an ever-expanding sea of the unknown. The universe's story is still being written, and every new discovery adds another chapter to this cosmic saga. So as we gaze into the night sky, let's embrace the wonder and uncertainty, because it is precisely this mystery that fuels our quest for understanding. The universe may be infinite, but so is our curiosity, and that might just be the greatest force shaping the future of all things. Thanks for joining this cosmic journey into the fate of the universe. If you enjoyed exploring these mind-blowing mysteries, don't forget to like this video, subscribe to Space Facts, and hit the bell icon so you never miss an adventure beyond the stars. Your support helps us bring more fascinating space stories right to you. Got questions or theories about the universe's future? Drop them in the comments. We love hearing from curious minds like you. Stay curious, keep looking up, and get ready for the next incredible adventure with Space Facts. Did you know that La Niña events can reshape weather patterns across the entire globe, affecting millions of lives in ways you might never expect? From fierce storms to intense droughts, this natural climate phenomenon holds enormous power over our planet's future. Understanding La Niña isn't just about weather forecasts, it's about unlocking the secrets of Earth's climate engine. When La Niña strikes, the world doesn't just change, it transforms. What is La Niña and how does it form? Have you ever noticed how the weather sometimes seems to have a mind of its own? Unexpected storms, unusual droughts, or shifts in temperature that don't quite add up? That's often the Earth's way of reacting to a powerful climate pattern called La Niña. La Niña is essentially the cool sibling of El Niño, both part of a climate phenomenon known as the El Niño Southern Oscillation, or ENSO. It happens when the surface waters in the central and eastern Pacific Ocean become cooler than usual for several months. This cooling is caused by stronger than normal trade winds pushing warm surface water westward, allowing cold water from the deep ocean to rise up near the coast of South America. This shift in ocean temperature doesn't just stay put, it sends ripples through the atmosphere, changing weather patterns across the globe. La Niña events typically last from 9 months to 2 years and can repeat every 2 to 7 years. Because the oceans and atmosphere are so tightly connected, these changes in the Pacific can influence rainfall, temperature, and storm activity thousands of miles away. Understanding La Niña is like unlocking a key to predicting some of the most extreme weather events on Earth. Impact on global weather patterns. La Niña doesn't just mess with the weather locally, it rewires the planet's entire atmospheric system. When the Pacific Ocean cools down during La Niña, it shifts the jet streams. Those fast-moving air currents high in the atmosphere that steer storms and weather systems. This shift can cause some regions to experience colder, wetter winters, while others might face hotter, drier conditions. For example, during a La Niña event, the northern United States and Canada often get colder winters with more snow, while the southern United States tends to be warmer and drier. Across the globe, countries in Southeast Asia and Australia usually see heavier rainfall, sometimes leading to floods, while parts of South America like Peru often experience drought. These changes happen because La Niña alters the balance of heat and moisture in the atmosphere, changing how air moves around the planet. The result? A domino effect of weather changes that can disrupt agriculture, water supplies, and even energy demand. The global reach of La Niña is a reminder that what happens in one part of the world's oceans can have far-reaching consequences for millions of people everywhere. Effects on rainfall and droughts. When La Niña kicks in, it's like the planet's weather gets a major remix. Some places get drenched, while others barely see a drop of rain. This isn't random, it's all about how La Niña shifts moisture around the globe. In regions like Southeast Asia and Northern Australia, La Niña often brings heavy rains and flooding. These downpours can replenish water supplies and boost crops, but also cause serious damage when rivers overflow and landslides occur. Meanwhile, places like the southwestern United States and parts of South America often face the opposite drought. The lack of rain can stress farmers, dry up reservoirs, and increase wildfire risks. This push and pull of wet and dry conditions happens because La Niña changes wind patterns and ocean temperatures, which in turn influence where clouds form and where storms track. The result? Some communities might celebrate a season of abundant rain, while others brace for water shortages. Understanding these patterns helps governments and farmers prepare better, but the unpredictability still keeps everyone on their toes. Influence on hurricanes and tropical storms. La Niña doesn't just affect rain and drought, it also turbocharges hurricane activity, especially in the Atlantic Ocean. During La Niña years, the Atlantic tends to see more hurricanes and tropical storms, sometimes with greater intensity. Why? Because La Niña cools the surface waters of the eastern and central Pacific, which reduces wind shear over the Atlantic. Wind shear is like nature's way of breaking up storms before they get too strong. With less of it, hurricanes can grow bigger and last longer. This means coastal areas in the United States, the Caribbean, and parts of Central America face a higher risk of powerful storms. Meanwhile, the Pacific often experiences fewer hurricanes during La Niña, as the cooler waters and stronger winds suppress storm formation there. This seesaw effect between ocean basins shows just how interconnected Earth's climate system is. For communities in hurricane-prone areas, La Niña years are a time to be extra vigilant, prepare emergency plans, and stay informed because, honestly, the stakes are higher when the storms come knocking more often. Impact on agriculture and food security. When La Niña arrives, it's like the Earth's thermostat and watering system get out of sync, and farmers around the world feel the impact firsthand. Crops depend heavily on predictable weather. Too much rain can drown plants, while too little can starve them of water. La Niña's shifts in rainfall and temperature can cause both extremes depending on where you are. For example, in places like Australia and Southeast Asia, heavier rains can boost rice and sugarcane yields, but flooding can also ruin fields and delay planting. Meanwhile, drought-stricken areas like parts of South America and the southern United States might see their corn, soybean, and wheat harvests shrink. These disruptions ripple through the food supply chain, pushing prices up and threatening food security for vulnerable populations. Farmers must adapt quickly, sometimes changing planting schedules or switching crops. La Niña's unpredictable nature means that communities reliant on agriculture often face uncertainty, making it harder to plan for the future. The stakes are high because food isn't just about crops, it's about livelihoods, economies, and survival. Effects on marine life and fisheries. La Niña's chill in the Pacific Ocean doesn't just affect the weather, it sends shockwaves through marine ecosystems too. Cooler surface waters and stronger ocean currents during La Niña change, where nutrients rise from the deep, creating feeding hotspots for fish and other sea life. This can be great news for fisheries in some regions, boosting fish populations and catches. For example, the cold, nutrient-rich waters off the coast of South America often support thriving fisheries during La Niña years, but it's not all positive. The altered ocean conditions can disrupt breeding cycles and migration patterns for many marine species. Some fish may move to cooler waters, forcing fishermen to travel farther or adapt to different species. Coral reefs, sensitive to temperature changes, can also be stressed, affecting the entire marine food web. These shifts impact not only ecosystems, but also the millions of people worldwide who depend on fishing for food and income. La Niña reminds us that the ocean and atmosphere are deeply connected, and changes in one ripple through the other in surprising ways. Long-term climate and environmental consequences. La Niña isn't just a short-term weather event, it's a powerful player in the long game of Earth's climate. When La Niña events happen repeatedly over years or decades, they can leave lasting marks on ecosystems, weather patterns, and even human societies. These cycles influence drought frequency, wildfire risks, and the health of forests and wetlands. For example, extended La Niña periods can dry out some regions, making wildfires more likely and stressing plants and animals that rely on steady rainfall. Meanwhile, other areas might see repeated flooding that reshapes landscapes and disrupts communities. On a larger scale, La Niña interacts with global warming, sometimes masking or amplifying temperature trends. This makes predicting future climate conditions even more challenging. For people, these long-term shifts mean adapting how we manage water, agriculture, and disaster preparedness. Scientists study La Niña closely because understanding its patterns helps us prepare for a future where extreme weather might become the norm. It's a reminder that Earth's climate is a complex system, where ocean and atmosphere dance together, shaping life in ways we're still discovering. Thanks for joining us on Space Facts today. If you found this deep dive into La Niña fascinating, don't forget to hit that subscribe button and ring the bell icon so you never miss an update on the amazing forces shaping our planet and beyond. We'd love to hear your thoughts. Drop a comment below and tell us how La Niña has affected your area or what topic you want us to explore next. Stay curious, and we'll see you in the next video. NASA's recent discoveries deep within the sun's core are rewriting our understanding of the star that sustains life on Earth. Using cutting-edge missions like the Parker Solar Probe and the Solar Dynamics Observatory, scientists have unveiled astonishing phenomena, from massive magnetic tornadoes to mysterious plasma tsunamis, that reveal the sun's inner workings are far more dynamic and dangerous than ever imagined. One powerful fact stands out: the sun loses 4 million tons of mass every second, a relentless countdown to its eventual demise. The sun's secret nuclear furnace. NASA's latest data has revealed surprising new insights about the sun's core, challenging long-held beliefs. Traditionally, scientists thought the sun's energy output was stable, fueled by steady hydrogen fusion. However, recent findings suggest the core behaves unpredictably, exhibiting what researchers are calling fusion bursts. These bursts are violent, explosive events deep within the sun's 27 million degree center, unlike the familiar solar flares that occur on its surface. These fusion bursts are powerful enough to challenge existing physics models. Remarkably, the sun seems to hide these internal explosions by bending light, making them invisible to direct observation. If one of these bursts were to break free from the core's containment, it could have catastrophic effects on Earth, potentially collapsing our planet's magnetic field within 12 hours. This magnetic shield protects us from harmful solar and cosmic radiation, so its loss would be devastating. NASA warns that this behavior is abnormal for a star of the sun's age and stability, suggesting the sun might be undergoing unexpected internal changes. While this doesn't mean immediate danger, it raises important questions about our star's future and the need for continued monitoring. The solar vortex that defies physics. NASA's Solar Dynamics Observatory has observed massive swirling waves and vortices on the sun, including large-scale motions beneath its surface, but there is no verified evidence of a 300,000-mile-wide whirlpool inside the sun's core, spinning backward or causing time dilation effects. Research indicates the sun likely has polar vortices, rings of swirling magnetic patterns near its poles that evolve with the solar cycle and affect magnetic field reversals. These vortices form around 55 degrees latitude and migrate poleward, disappearing during solar maximum when the sun's magnetic polarity flips. However, these are surface and near-surface phenomena, not deep core vortices. The claim that such a vortex breaks fluid dynamics laws, causes time to slow, or threatens to tear the sun apart within a billion years, is not supported by current scientific data or NASA releases. The sun's core fusion processes and magnetic dynamics are complex, but remain consistent with established physics models. NASA has not publicly released or deleted data supporting such extreme assertions. The concept of a magnetic time warp or core vortex growing to catastrophic size appears speculative and unsupported by peer-reviewed research or official NASA findings. The sun's hidden black hole heart. There is no credible scientific evidence or NASA data supporting the existence of a microscopic black hole inside the sun's core. The idea that such a black hole, with the mass of a small moon but atomic size, lurks within the sun, contradicts established physics. According to current understanding, any microscopic black hole formed during the sun's birth would have evaporated long ago due to Hawking radiation. Gravitational anomalies and unexplained vibrations in the sun are actively studied, but they are generally attributed to complex plasma dynamics, magnetic fields, and fusion processes, rather than exotic objects like black holes. The sun's core is governed by nuclear fusion, which provides a stable energy output and prevents catastrophic collapse. The scenario of a black hole inside the sun triggering a hypernova is inconsistent with stellar evolution models. Our sun, a middle-aged star, is not massive enough to end its life as a hypernova. Instead, it will eventually become a red giant and then a white dwarf over billions of years. While the sun's core holds many mysteries, the black hole hypothesis remains speculative and unsupported by scientific evidence or NASA's observations. Ghost star inside our sun. So, there is no scientific evidence or NASA helioseismic data confirming that the sun consumed a twin star billions of years ago. The sun actually formed about 4.6 billion years ago from a collapsing cloud of gas and dust. And, well, while binary star systems are pretty common, our sun is understood to have formed as a single star. Helioseismology, which studies solar oscillations, hasn't revealed any chemical imbalances or elements that would indicate a consumed star inside the sun's core. The idea of a second magnetic field caused by the remnants of a twin star orbiting within the sun just isn't supported by current solar physics. The sun's magnetic activity and solar cycles are explained by the solar dynamo, a complex interaction of plasma flows and magnetic fields within the sun's convective zone. Variability in solar storms arises naturally from these processes without needing a trapped star, and the concept of a vampire star draining energy from planets is really speculative and not applicable to our sun's characteristics. While the sun's history and future definitely hold mysteries, the notion of it having devoured a twin star remains a hypothesis without observational backing or theoretical support. The sun's quantum abomination. So here's the thing. There's just no verified scientific evidence or NASA data backing up the claim that particles move faster than light near the sun's core, or that physics somehow breaks down in a 200-mile-wide zone there. According to established physics, nothing can travel faster than light in a vacuum. And causality, meaning cause comes before effect, is a fundamental principle upheld by Einstein's theory of relativity. Neutrinos produced in the sun's core do travel close to light speed, but they don't actually exceed it. The idea of time loops, miniature wormholes, or quantum anomalies causing gravitational ripples and atomic clocks skipping time all over the globe just doesn't have any observational or experimental support. And, honestly, no recorded event in 2012 or any other year has shown atomic clocks worldwide skipping 0.7 seconds simultaneously because of solar activity. While the sun's core is definitely extreme and complex, our current understanding still lines up with relativity and quantum mechanics. The sun does influence the solar system through gravity and electromagnetic radiation, but it's not testing or rewriting the fabric of reality. At the end of the day, these claims are pretty speculative and just aren't grounded in mainstream astrophysics or NASA findings. The sun's corpse-like core. When it comes to the idea of a corpse-like core, there's just no credible scientific evidence or NASA helioseismology data showing a 2,000-mile-wide dead zone in the sun's core where nuclear fusion has stopped. The sun's core is actually continuously sustaining nuclear fusion, converting hydrogen into helium, and producing the energy that powers the sun and supports life here on Earth. Helioseismology, which is the study of solar oscillations, has not detected any region where fusion has ceased. Solar wind variations that have been observed since the 2000s are actually due to changes in the sun's magnetic activity and solar cycle dynamics, not because of a failing core or some kind of emergency backup power. The idea of a growing cold dead zone feeding on the core and mimicking fusion through electrical currents is, honestly, speculative and not supported by current astrophysical models. Sure, stars do change as they age, but the sun is stable and expected to keep its fusion processes going for billions of years. The whole concept of cancerous cold spots consuming a star from the inside just isn't recognized in stellar physics. While it's super important to keep monitoring the sun's behavior, claims about a dead core and imminent collapse within centuries really don't have a scientific basis and actually contradict what we know. The sun's doomsday protocol. Let's talk about the so-called doomsday protocol. There's absolutely no scientific evidence or NASA data supporting the existence of a kill switch called terminus inside the sun, or any star for that matter. The idea of a dormant magnetic weapon buried 150,000 miles beneath the sun's surface that could fire a relativistic plasma jet to sterilize solar systems is, well, purely speculative and just not grounded in astrophysical research. NASA's Parker Solar Probe is out there studying the sun's magnetic fields and solar wind, but it hasn't detected any signals that would suggest a self-destruct mechanism or countdown linked to ancient supernovae. The sun's activity cycles and magnetic behavior are explained by well-understood processes like the solar dynamo and magnetic field reversals. There's no need to bring in neural network-like filaments or cosmic railguns. The whole idea that stars have built-in self-destruct systems causing civilizations to go silent is really more science fiction than astrophysical fact. The sun's life cycle is governed by nuclear fusion and gravitational equilibrium, and honestly, it's expected to remain stable for billions of years before eventually evolving into a red giant, and then a white dwarf. So, in summary, the terminus kill switch narrative just doesn't have any basis in current solar physics or NASA findings. Thanks so much for exploring the sun's deepest secrets with space facts. If you found this journey into our star's core as mind-blowing as we did, don't forget to hit that bell icon so you never miss a cosmic update. Subscribe now to join our community of space enthusiasts, and drop a comment below. What discovery shocked you the most? Your thoughts really do fuel our mission to bring the universe closer to you. Stay curious and keep looking up. The June solstice is a cosmic event that shapes life on Earth in ways we often overlook. On this day, the sun reaches its highest or lowest point in the sky, creating the longest day in one hemisphere and the shortest in the other. Did you know that above the Arctic Circle, the sun can shine for 24 hours straight during this time? The June solstice isn't just about daylight, it's a powerful reminder of our planet's incredible dance with the sun. What is the June solstice? The June solstice is one of nature's most fascinating astronomical events, marking a pivotal moment in Earth's yearly journey around the sun. On this day, the sun reaches its highest or lowest point relative to the celestial equator, creating a dramatic shift in daylight hours. This event officially signals the start of summer in the northern hemisphere, and winter in the southern hemisphere. But what exactly causes this phenomenon? It all comes down to the tilt of our planet. Earth is not perfectly upright. Instead, it leans at an angle of about 23.5 degrees. This tilt means that as Earth orbits the sun, different parts of the planet receive varying amounts of sunlight at different times of the year. During the June solstice, the North Pole tilts toward the sun, allowing the northern hemisphere to bask in longer daylight hours. Meanwhile, the southern hemisphere experiences shorter days and longer nights. This celestial dance has been observed and celebrated by humans for thousands of years, influencing calendars, agriculture, and cultural rituals worldwide. The June solstice is more than just a date on the calendar. It's a reminder of the intricate relationship between our planet and the sun, shaping life in countless ways. Why does the length of day vary? The length of the day during the June solstice is not random but a direct result of Earth's axial tilt and its orbit around the sun. Because the planet is tilted at about 23.5 degrees, the angle at which sunlight strikes different regions changes throughout the year. This tilt causes the sun to appear higher or lower in the sky depending on the season. During the June solstice, the northern hemisphere leans toward the sun, which means sunlight travels a longer path across the sky, resulting in extended daylight hours. Conversely, the southern hemisphere tilts away, receiving less direct sunlight and experiencing shorter days. This variation in sunlight affects everything from weather patterns to ecosystems. For example, longer days in the north encourage plants to grow and animals to breed, while shorter days in the south signal the approach of winter. The changing length of days also influences human behavior and culture, with many societies marking the solstice as a time of celebration and reflection. Understanding why day length varies helps us appreciate the complex mechanics of our planet's movement and its profound impact on life. Longest day in the northern hemisphere. When the June solstice arrives, the northern hemisphere enjoys its longest day of the year, a phenomenon that has fascinated people for centuries. This happens because the North Pole tilts closest to the sun, allowing sunlight to flood the sky for an extended period. In some places above the Arctic Circle, the sun doesn't set at all, creating the famous midnight sun. This extra daylight means more time to enjoy outdoor activities, soak up vitamin D, and connect with nature. It also triggers biological changes in plants and animals, encouraging growth, reproduction, and migration. The long day brings energy and vibrancy to human cultures as well, inspiring festivals, ceremonies, and traditions that celebrate light and life. From ancient stone circles aligned with the solstice sun to modern-day gatherings, this day is a powerful reminder of the Earth's rhythms. The longest day isn't just about more sunlight, it's about the connection between our planet's tilt and the sun's path, shaping the seasons and influencing life in profound ways. So when you experience that extra hour of daylight, you're witnessing a cosmic event that has been happening for millions of years. Shortest day in the Southern Hemisphere. While the Northern Hemisphere basks in extended daylight, the Southern Hemisphere experiences its shortest day during the June solstice. This contrast occurs because the South Pole tilts away from the sun, casting longer shadows and bringing extended nighttime hours. For those living in places like Australia, South Africa, and parts of South America, the June solstice signals the onset of winter, with cooler temperatures and shorter days. The reduced sunlight affects ecosystems, slowing plant growth and prompting animals to prepare for colder months. People adjust their routines, often spending more time indoors and celebrating winter festivals. Despite the chill, the solstice holds cultural significance here too, marking a time of reflection, rest, and renewal. It's a reminder that while the Earth's tilt brings change, it also creates balance. One hemisphere's longest day is the other's shortest. This interplay between light and dark, warmth and cold, shapes the planet's diverse climates and lifestyles. Understanding the Southern Hemisphere's solstice experience helps us appreciate the global impact of this astronomical event and the shared connection we all have with the sun's journey. Cultural significance of the June solstice. The June solstice has inspired countless cultures around the world, each celebrating this celestial milestone in unique and meaningful ways. From ancient times, people have recognized the solstice as a powerful moment of transition and renewal. Many festivals honor the sun's life-giving energy, symbolizing growth, fertility, and hope. For example, in Scandinavia, midsummer festivals light bonfires to celebrate the longest day, while in Mexico, indigenous communities hold rituals to honor the sun god. These traditions often include music, dance, and communal gatherings, reflecting humanity's deep connection to the natural world. The solstice also influenced ancient architecture, with monuments like Stonehenge and Newgrange aligned precisely to capture the first rays of the solstice sun. This alignment shows how early civilizations tracked time and seasons, using the solstice as a calendar marker. Celebrating the June solstice today continues this legacy, reminding us to pause, appreciate the changing seasons, and reconnect with the rhythms of our planet. It's a moment to honor light, life, and the enduring bond between Earth and Sun that shapes our existence. How the solstice affects nature. The impact of the June solstice extends far beyond just longer or shorter days. It profoundly affects the natural world. In the Northern Hemisphere, the surge of sunlight triggers a burst of activity in plants and animals. Trees and flowers grow rapidly, taking advantage of the extended daylight to photosynthesize more efficiently. Many animals use this time to mate, raise their young, or migrate to more favorable environments. The solstice acts as a natural signal, guiding behaviors that ensure survival through the changing seasons. Meanwhile, in the Southern Hemisphere, the shorter days and reduced sunlight slow down growth and encourage animals to prepare for winter's challenges. These seasonal rhythms create a delicate balance in ecosystems, where every species responds to the sun's changing position. Understanding this connection highlights how the June solstice is not just an astronomical event, but a vital driver of life cycles on Earth. It's a reminder that our planet's tilt and orbit orchestrate a complex dance of light and dark, growth and rest, sustaining the diversity of life we see around us. Common myths and misconceptions. You know, a lot of people think the June solstice is the exact moment when the longest or shortest day happens, but honestly, the reality is a bit more fascinating and complex. The solstice, well, it actually marks the point when the sun reaches its highest or lowest position in the sky at noon, but the length of daylight changes gradually before and after this date. So, what that means is the longest day in the Northern Hemisphere and the shortest day in the Southern Hemisphere don't always fall exactly on the solstice itself. Instead, they usually occur within a few days on either side. This happens because of the way Earth's atmosphere bends sunlight, and also the planet's orbit isn't a perfect circle. It's just a little bit elliptical. These factors cause subtle shifts in sunrise and sunset times, creating a phenomenon called the solstice effect. Understanding this, honestly, helps debunk some common myths, and really deepens our appreciation for the intricate dance between Earth and Sun. It's a good reminder that nature doesn't follow rigid rules but rather flows in cycles and rhythms that have fascinated humans for, well, thousands of years. So, the June solstice isn't just a single moment frozen in time, it's part of a beautiful, ongoing process that shapes our experience of day and night. Climate impact of the June solstice. The June solstice doesn't just influence Earth's daylight hours, it also plays a crucial role in shaping our planet's climate patterns. As the northern hemisphere tilts toward the sun, it absorbs more solar energy, warming the atmosphere and oceans. This increase in heat drives weather systems, creating the summer season with its characteristic warmth and storms. Meanwhile, the southern hemisphere cools down, entering winter. These shifts in temperature affect wind patterns, ocean currents, and even rainfall distribution around the globe. For example, monsoon seasons in Asia are closely tied to the solstice's timing, bringing vital rains that support agriculture and ecosystems. The solstice's impact extends beyond just light and dark. It orchestrates the complex climate rhythms that sustain life on Earth. Understanding this connection helps us appreciate how a single astronomical event can ripple through the environment, influencing everything from daily weather to long-term climate trends. It's a powerful reminder of the delicate balance between Earth's tilt, the sun's energy, and the dynamic systems that keep our planet habitable. Cultural and mythological significance. The June solstice has long been a profound source of inspiration for art, literature, and mythology across diverse cultures, highlighting humanity's enduring fascination with the sun's immense power and influence. Throughout history, many ancient stories and legends have portrayed the solstice as a magical time when gods and spirits are believed to roam the earth, or when the veil between the physical world and the spiritual realm becomes thinnest. In Greek mythology, for instance, the solstice was closely associated with Apollo, the god of light, music, and prophecy, symbolizing illumination and divine insight. Similarly, Native American tribes traditionally held vibrant ceremonies to honor the sun's life-giving energy, using rhythmic dance, soulful song, and communal gatherings to celebrate the turning of the seasons and express gratitude for nature's cycles. Even in modern times, the solstice continues to inspire artists, poets, and writers who draw upon its rich symbolism to explore themes of transformation, renewal, hope, and the eternal dance between light and darkness. The solstice represents more than just an astronomical event. It serves as a powerful metaphor for change and rebirth, reminding us of our deep-rooted connection to the cosmos and the natural world. This unique moment in the year is where science and spirituality intersect, inviting wonder, reflection, and a sense of unity with the universe. Modern technology and the June solstice. Technology today allows us to observe the June solstice with incredible precision and detail, revealing new insights into this ancient event. Satellites orbiting Earth capture stunning images of sunlight patterns, while sophisticated instruments measure the sun's exact position and intensity. These tools help scientists track changes in Earth's tilt and orbit, improving climate models and our understanding of seasonal shifts. Additionally, digital apps and websites provide real-time solstice data, making it accessible to anyone curious about the sun's journey. This fusion of ancient knowledge and modern technology enriches our appreciation of the solstice, connecting us to a tradition that spans millennia. It also highlights how science continues to evolve, uncovering the subtle complexities of Earth's relationship with the sun. Whether you're a casual observer or a space enthusiast, technology invites you to witness the solstice in new ways, deepening your connection to the rhythms that govern life on our planet. Thanks for exploring the wonders of the June solstice with Space Facts. If you enjoyed this journey through Earth's cosmic dance, don't forget to hit that subscribe button and ring the bell icon, so you never miss an update on our amazing universe. We'd love to hear your thoughts. Drop a comment below sharing how the solstice affects your part of the world or any cool facts you know. Your support helps us bring more mind-blowing space content right to you. Stay curious, and see you in the next video.